Hey, this is Mr. Mitchell with a little bit more about electricity. I'm sure you've had before about the difference between series and parallel circuits, and I'd like to reinforce that. Series circuit, whenever you have direct current, you have the electrons flowing through the wire, and in this case, every single electron or every single light bulb is lit because of the current that's going through the wire. And this goes one after the other in kind of a series of light bulbs. So the thing about series circuits is that if you do have a break anywhere along this circuit, then all three light bulbs will go out because it is along the circuit, which is okay. It's just something that you need to know will happen whenever you're setting up a series circuits and you wanting these lights. Sometimes you have a Christmas tree lights which will be in a series circuit like this. Go to one, to the next, to the next, to the next. And if any one of these kind of has a break in the circuit, then all of them go out. And that used to be very common whenever I was younger on the Christmas tree. But as far as Christmas trees goes, probably a better way to do it is parallel circuit. Now you can see there's more involved in making a parallel circuit. But what you have here is the electrons flow, but it's not just in one circuit, it is in like three circuits in one. So what you have is, as long as the electrons are flowing, it continues to light all three. But if there happens to be some kind of problem on these inside circuits, now they're flowing through there, but if you have a disconnection on this first one, the first light bulb will go out while the others will continue going because you still have the circuit which will be made for these. I think in the last video we talked a little bit about alternating current. We just mentioned that these are examples of direct current, and alternating current is where you have the current alternates. It isn't direct, and I think I remember mentioning before that alternating current happens like about 120 times a second. And it's a little more complex than the direct current, which just goes straight from one place to the next. So let me try to explain alternating current. And to do so, you have to see what's going on with a wire and with something called an electromagnet. If you have a wire that has a circuit, has electrons running through it, it actually has a magnetic field going around the wire. And that's going to be true even with the wires that you have in your home. It's just not a huge magnetic field. But the right-hand rule, I'm using it to show you that it does have a magnetic field, but there is a predictable way to see the direction of that current. If you have the current going in one direction, like where your thumb is sticking up, the magnetic field is going to go around that wire in the directions that your fingers are pointing. So right-hand rule will tell you the direction of the magnetic field if you know the direction of the current by holding out your right hand, and that will tell you that. Now, that being said, that goes to show you that when you have a wire that is wrapped around this nail here, you've gotten a current going through it from the battery, it's going to create a magnetic field. So what it actually does, if you put some kind of conductible metal in there, like a nail, it actually makes this nail magnetic. And you can see this depiction here. You've got basically the same setup, except this nail here is now magnetic when you put a current through there. So when you put the current through there, then you have a magnetized nail. Now, what does it do to the current? It actually makes the current stronger. So if you can have conductible materials with wire wrapped around them and send a charge through them, you have a stronger magnet and you have a stronger current. This is what's called an electromagnet. So what does that have to do with alternating currents? than electromagnetic magnet like you have up here? Well, let's apply this. It's Faraday's law. You don't have to know who Faraday is. He discovered it. But it says an electric current can be produced in a circuit by changing the magnetic field. So up here you have an electromagnet, and you have the same type thing going on down here. You have a magnet which is going through like the nail turns out to be, but these magnets also have an electric field. It's called, well, a magnetic field. So when you couple this magnetic field with the field of the electric field, you can produce electricity in greater than what was already going through here. So as the magnet gets close to the coiled wires, you have an increase of electricity. But whenever it gets farther away, you have not an increase of, well, I should have said an increase of ions. Notice what's happening here on this galvanometer, which registers the ions. It's going toward the negative. Whenever it goes in and then goes away, then it goes from negative to positive. The current direction of the current has changed. So people have figured out you can manipulate a magnet with coiled wires and create electricity. And the movement comes within the magnet going back and forth. And in this case, what people have figured out is a setup kind of like this. This is where you have the magnets north and south here, and you have the wire that's going through. Now, I failed to mention earlier here that whenever you have an electromagnet, I'll go back here, whenever you have an electromagnet, that you can change the north and the south end of the poles by moving it around. And the same thing happens here, that whenever you put this magnet in the coil or loop, it flips the north and the south end. So people have figured out that if you can run electricity through a coil like here, and you can move it, you can rotate the coil, then that constantly gets a change from north to south. And whenever you change the magnetic field, you produce electricity. So yes, this little contraption here with the wires produces electricity because the wires are moving and it changes the magnetic field. And the energy you have to put into this is getting the wires to move. And that's something for another time that we'll talk about how to get the wires to move. So that's how you have alternating current, by altering the magnetic field to produce electricity. And that's how most of our electricity, our household electricity, is produced. Hope you learned something about AC.